Have you ever imagined that how much height you can suck up the water through a straw? Let's see an example. Once my friend told me that he wanted to drink the water from the cliff by placing a bucket of water in the ground and using a straw he wanted to suck up the water from the bucket. And I say yes, it's a good idea. There are more madmen than him in the world, so he can do anything he wants. And he starts the drinking by sucking up through the straw. And the water gets rising through the straw to a midway. After that point, the water does not get risen. The water is still there. He is trying his hard to suck up the water but does not rise a little bit from that position. So what is going on here? Why does it like this? This is our straw and this is a bucket and there's a lot of air particles here and he is sucking from this side. Whenever he sucks some of the air particles. That's why some of the air particles get lost. And we know that whenever the air density is reduced, the pressure is also reduced. And the pressure in this region is reduced to P. And we know that the pressure in this range, this area is PA, this area. So the pressure at the two sides are PA and this side is P. But we know that the water at the same height should have the same pressure. So this pressure must be PA, but it is P. So this water get increased their height to some level here. And we know that the pressure in this region is PA and in this region is P. And the difference in the pressure is the pressure exerted by this water column, this water column in this area. What is that? That is nothing, that is H rho G, where H is this height. So we can write as PA minus P because PA is greater, P is lesser. PA minus P should be equal to H rho G. Or P will be equal to PA minus H rho G. This is the idea. Now again he sucks up the water. What happens? The air molecules get reduced again. That's why the pressure gets reduced again. So the water increases its height to some more level. Now you can see that there is a smaller amount of air here, only 3 molecules. That's why the pressure is extremely low. So he sucks up more, then this much air will also lost. And there is nothing here. So what happens? The pressure in this region will become 0. That this time will become 0. So that means if he sucks up again, he does not get any air. This is exactly like a vacuum. That means that there is nothing. He sucks up, he does not get anything. That's why this time is 0. So PA will be equal to H rho G. That we can find the height in which the pressure became 0. And the height became the PA divided by rho G. And if you calculate the value of the H, it is approximately equal to 10 meters. That's why he cannot suck up the water through the straw in the previous case. The cliff is about 20-meter height and the midway is about 10 meters. That's why there is a vacuum only in the straw. There is no air particle, so he cannot suck up the water through it. He sucks, he does not get anything.